Hello everyone, I am Noor Zainab and I hope you all are doing well. In today's video, I'm going to discuss about series combination of capacitors, and by the end of this video, we will learn that how we can derive the equivalent capacitance of a series combination of capacitors. A capacitor is a device that stores both electric charges as well as electrical energy. The electrical energy is stored between the plates of the capacitor in the form of electric field, whereas the electrical charges are stored on the plates of the capacitor. This ability of the capacitor to store charge is known as capacitance, and the SI unit of capacitance is farad. The more the charge is stored on the plates of the capacitor, the more voltage is produced between the plates of the capacitor. So we can say that the charge Q which is stored on the plates of the capacitor is directly proportional to the voltage V which is produced between the plates of the capacitor. If we remove this proportionality sign, we have to place a constant value, and this constant value is the capacitance, which is the ability of the capacitor to store charge. If we have two or more capacitors which are joined end to end, they are said to be in a series combination. So now let's discuss two main properties of a series combination. In a series combination, same charge is produced on each capacitor. All the capacitors in a series combination carry the same charge Q. The second property of a series combination is that the voltage splits. The total voltage across the series combination is the sum of the individual voltages across each capacitor. It means that the voltage which is supplied by the battery is divided across each capacitor. So in case of series combination, the same charge Q is produced and the voltage is different, and it also applies in the series combination of resistors and inductors. Whereas in parallel combination, the voltage is same, it is the potential difference is same. So P for potential difference and P for parallel combination. Whereas the charges are different in case of parallel combination. Now here you can see parallel and series combination of three different circuit components. By the end of this video, you will also understand that why in series combination of capacitors the capacitance is decreased, whereas in case of series combination of resistance the resistance is increased. So now let's consider a series combination of capacitors. Let C1 be the first capacitor, C2 be the second capacitor, and C3 be the third capacitor. The three capacitors are joined with each other in a series combination with a battery which provides the voltage V. Let the points be named as A and B. The charges are induced on the plates of the capacitor plus Q and minus Q. The charge on the plate which is connected to the positive terminal of the battery is plus Q, and the charge on the plate which is connected to the negative terminal of the battery is minus Q. Charges are then induced on other plates of the capacitor, and in this way we can say that the same charge Q is induced on each plate of the capacitor. The voltage which is provided by the battery is V. If we calculate the potential difference across each capacitor, we will see that the voltage is different across each capacitor. We will see that the potential difference across the capacitor C1 is V1, whereas the potential difference across the capacitor 2 is V2, and the potential difference across the third capacitor is V3. The total voltage V which is provided by the battery is split across the capacitors C1, C2 and C3. The potential difference across capacitor C1 is different from the potential difference across the capacitor C2. This is because all the capacitors are having different values of capacitance. So we can say that across each capacitor same charge is induced, same charge is present on each of the capacitor, whereas there are different voltages across each capacitor. This is because of the different values of the capacitances. The sum of all the voltages is equal to the voltage which is provided by the battery. So we can say that the potential drops across the capacitors C1, C2 and C3 are due to different values of the capacitances of the capacitors. As we know the formula of voltage, which is V is equals to Q divided by C. This formula comes from the main formula which we discussed earlier, which is Q is equals to CV. So here you can clearly see that the voltage across each capacitor will be different if the capacitances are different. So all these three voltages are different. It is that the main voltage is split across each capacitor, whereas same charges are present across each capacitor. So now we can say that all capacitors of a series combination have the same charge Q. This occurs due to the conservation of charge which exists in the circuit, whereas the potential differences across the capacitors sum up or add to the voltage of the battery. Furthermore, when multiple capacitors are connected in a circuit, they can also be replaced by a single equivalent capacitor that has the same overall effect on the circuit. Equivalent capacitance, which is also sometimes known as the total capacitance, is the single capacitance value that can replace a group of capacitors connected in a circuit. So here we are having three capacitors. We can replace these three capacitors with a single capacitor. This single capacitor is known as an equivalent capacitor and its capacitance is known as equivalent capacitance. So this series combination of three capacitors resembles a single capacitor, which is an equivalent capacitor with a smaller capacitance. In series combination, the equivalent capacitance is reduced. So we can say that a series combination of two or three capacitors resembles a single capacitor with a smaller capacitance. So now let's derive the equation of equivalent capacitance if we have three or more capacitors which are joined to each other by a series combination. It means that if I have a capacitor C1 and a second capacitor C2 and a third capacitor C3, what is the total capacitance of this capacitor? So we are going to derive an equation of the series combination which will show us the total or equivalent capacitance of these three capacitors. So in order to derive the equation of the equivalent capacitance, as we know that the charges are same on each of the capacitor, whereas the potential drops or the voltages are different. So we're going to derive the equation by starting with the thing which is different. It means that the voltages are different, so we're going to start the derivation from the voltages. So first of all, we can say that the total voltage V which is provided by the battery is equals to the sum of each of the voltages. It means that the total voltage which is provided by the battery is split into each of the capacitors. So as the potential drops are different across each capacitor, now we are going to put the value of the voltage across each capacitor. As we know that the formula of potential difference V is equals to Q divided by C, we will put this formula in the above equation. So by putting this formula of voltage in the above equation, we get the new equation. In the new equation, we can clearly see that the charges are same, whereas the capacitances are different. That's why the voltage is different across each capacitor. In this equation, we can take Q as common, which is the charge. If we bring the Q on the left side of the equation, there it will be divided, and both of these charges can be cancelled. And hence we get the equivalent capacitance of a series combination of capacitors. So when the capacitors are connected in a series combination, the total equivalent capacitance is decreased. Furthermore, the total or the equivalent capacitance of the capacitors in the series combination is always smaller than the smallest individual capacitance. So here you can see that the series combination of capacitors and the parallel combination of capacitors. In series combination, the equivalent or the total capacitance is decreased, whereas in case of resistors, the series combination, the total resistance of the circuit is increased in series combination. The series combination of resistors and capacitors is different. So now let's discuss the main points of the series combination of capacitors. Number one, always remember that in series combinations there is same charge. It means all the capacitors in the series combination carry the same charge. Number two, the voltage is split. It means that the total voltage across the combination is the sum of the individual voltages across each capacitor. And number three, the decreased capacitance. The equivalent capacitance of capacitors in series is always smaller than the smallest individual capacitance in the group, as you can see in the equation. Thanks for watching. Like, share and subscribe to my channel for more videos, and if you have any questions you can contact my email or ask in the comment section. I will reply as soon as possible. Thanks for watching.